Hello viewers, welcome to the electrodynamics problem series. Our today's question is tangential electric field just outside the conductor is zero, which has the surface charge density sigma. So we have to prove that conductor which has surface charge density sigma, the electric field, tangential electric field just outside the conductor is zero. The ways to prove this is consider a very thin surface which same has a surface charge density sigma, and we don't know about how the charge distribution is there. Let's say electric field at this side, the side 1 is in this direction, and electric field this. I'm taking this arbitrary, okay? You can take it your own. So consider a loop. Consider a loop like this. Okay. Now we know that closed loop line integral of electric field is 0. So E dot dl is equals to 0. For this component, this is a very small length. Let's say this is equals to del L and this is del L. And this length we will diminish this by saying that these are tends to 0. Okay. So the E1 dl, for I'm starting from this side, E1 components parallel to this del L length, which is say E1t. On resolving this to the del L length component, del L E1t del L, and this component, let's say be this T1 plus, I'm moving to this now, the electric field in opposite direction to the this length element. So E2 del L E2t negative of E2t del L plus T2t is equals to 0. As we are saying that the width of this loop is very small, so we can diminish this quantity, and we will left with E1t minus E2t del L, which shows us that del L not equals to 0, shows us that tangential component along a surface charge is equals to the tangential component at the other surface. Now came back to our question, which says that electric field just outside the conductor is 0. So we know that every components in this conductor is 0. As let's say this is one side and this is two side. If the electric field component, tangential component inside the conductor is 0, so then this component must be 0, which proves that E1t is equals to E2t is equals to 0. So E1t must be equals to 0 by this boundary condition. Okay. Next question is that we have to prove that just outside the conductor having surface charge density sigma, electric field is sigma by epsilon naught. Okay. Now from our previous question we can easily interpret that this has no component along electric field component. There is no electric field component along the tangents of this surface charge density. Every component must be perpendicular to this surface. So to calculate this sigma by epsilon or outside, to prove this, let's say again a surface having surface charge density sigma, and this time we will consider a surface, imaginary surface, these having a surface area dA. Okay, and the electric field same as like our previous one, this one and this one E2. So electric field, so by using the Gauss law, which is flux E dot ds is equals to Q by epsilon naught. Okay, now taking this also surface. So we have three surface 1, surface 2, and this 3 surface which is a curved surface. Okay, so electric field due to 1 and a surface dA plus, as a same trick we play here, that we will say that this length is so small and it will tend to 0, so I am not writing this, plus E2, and the vector component, area vector component is this side. So E2 on moving E2 dA, let's say this is in the n cap direction, so this is will be in the minus n cap direction, and normal component, sorry, okay, q by epsilon naught. So the charge enclosed in this volume is equals to q sigma dA, as this will contain in this surface sigma dA epsilon naught. So E1 n cap minus E2 n cap dA is equals to sigma dA by epsilon naught, which shows us that E1 n minus E2 n cap is equals to sigma by epsilon naught. Now move on to our question, which we have to show that just outside electric field is equals to sigma epsilon naught. Now we have two surface again, 1 and 2. The electric field just outside and minus electric field just inside is equals to 0. So we know that electric field E2n, which is equals to 0 inside the conductor. So E1n is equals to sigma by epsilon naught in cap direction. So the net electric field is equals to sigma by epsilon naught just outside the conductor for a surface charge density sigma. Thank you.